Welcome back, Algebra 2. We're going to be looking today at the even and odd properties of trig functions. So if we recall, a function is even if f of negative x equals f of x. An example of an even function, one that we're very familiar with, is this one here, f of x equals x squared, which we know is just a parabola. And an even function, we know, has opposite inputs that have the same outputs. So if I were to call this point right here x, this would be x comma f of x. And if I were to look on the other side where negative x is, and I were to look at the point that corresponds to that, that would be negative x comma f of negative x. And if you compare the two y coordinates here, you notice that they're equal to each other, right? The opposite inputs will have the same outputs. Another thing to note is that even functions do have a type of symmetry where they will be symmetric with respect to the y-axis. Hopefully that kind of reminds you of even functions, right, when we talked about that in the first semester. An odd function, if you remember, is one for which f of negative x equals negative f of x. An example of an odd function would be x cubed. And for an odd function, opposite inputs will have opposite outputs. So if I label this x, this point would be x comma f of x. And on the other side, if I call this negative x, the point that corresponds to that would be negative x comma f of negative x. And when you compare the two y coordinates, what you'll notice is that f of negative x is really the opposite value of f of x. And that's what this is saying right here, right? Odd functions also have a type of symmetry where they'll be symmetric with respect to the origin. And so these are even and odd functions. What we're going to be doing is we're going to be looking at the 6 trig functions, and we're going to figure out which ones are even and which ones are odd based on these definitions. And so let's go right into it. So we're going to start by drawing a unit circle, which is a circle of radius 1, centered at the origin. Let me draw an angle theta in standard position. And we talked about in the previous lessons how for a given angle theta, there's a point that always corresponds to an angle, and that x coordinate of that point will be cosine of theta, and the y coordinate of that point will be sine of theta. We're going to look at another angle. We're going to look at negative theta. Negative theta, if we draw it in standard position, would be going clockwise, right, because it's negative. And if we were to look at this point right here that corresponds to the angle negative theta, the x coordinate would be cosine of negative theta, and the y coordinate would be sine of negative theta. So we're going to be looking at these 2 points. In particular, we're going to be looking at their x coordinates. Here we have cosine of theta. Here we have cosine of negative theta. Now if you look at these 2 points, you should notice that they're both on the same vertical line. So what that tells me then is that cosine of negative theta must be the same value as cosine of theta, right? They have the same x coordinate, in other words. So if you remember earlier when we defined an even function, right, f is even if f of negative x equals f of x. Here, it's that same form, right? Cosine of negative theta equals cosine of theta. And so what this tells me then is that cosine is an even function. Now let's compare the y coordinates on my 2 points. Here I have sine of theta, here I have sine of negative theta. Now if you pay attention to the position of these 2 points, their y coordinates are opposites of each other. I can say that sine of negative theta is really going to be the opposite of sine of theta. And what this tells me is that sine is an odd function. So if you remember our definition of an odd function, we said f is odd if f of negative x equals negative f of x. You notice this is a very similar structure. And so we know that cosine is an even function and sine is an odd function. We'll be using these even and odd properties to better understand the tangent function. So let's look at tangent of negative theta. And we're going to determine whether this function is even or odd by using the fact that cosine is even and sine is odd. So tangent of negative theta, if you remember our quotient identities, this is the same thing as sine of negative theta over cosine of negative theta. And because we just said that sine is an odd function, sine of negative theta is the same thing as negative sine theta. And because cosine is even, I know cosine of negative theta is really just cosine of theta. You can pretend like that negative inside doesn't even exist. You can just drop it out. And from here, you can write this as negative sine of theta over cosine of theta, just pulling the negative to the front. And this is the same thing as negative tangent of theta. So all we did right now was we showed that tangent of negative theta equals negative tangent of theta. And hopefully, if you see something like this will remind you of an odd function. So this tells me that tangent is odd as well. And you could do something similar to the cosecant, secant, and cotangent functions to see whether they're even or odd. But let's fill out this chart here. So our even functions then, we said cosine was an even function, which means that cosine of negative theta equals to cosine of theta. You can pretty much just drop the negative. And if cosine is even, then it's going to follow that secant is an even function. So secant of negative theta will just equal to secant of theta. And then for the odd functions, we said sine was odd. So I know sine of negative theta equals negative sine of theta. Essentially that negative that's inside the trig function, you can just pull it to the front. And because sine is odd, I know that its reciprocal, the cosecant function, is also going to be odd. And then we said that tangent was an odd function. And because tangent is odd, it's going to follow that cotangent is also odd. So these even and odd functions are going to be very useful when it comes to evaluating trig functions at different angles. And it's also going to be useful when we graph, right? You'll be able to see clearly why these functions are even and odd when you look at the types of symmetries that the graphs have. Anyways, let's look right into our first example so we can see how we can apply these even and odd properties. So starting with number 1 here, we have sine of negative 15 pi over 4. Now, I know that sine is an odd function, and because sine is odd, what I can do is pull that negative out to the front. Again, because it's odd. And then from here, we're going to combine everything that we've learned up to now to evaluate negative sine of 15 pi over 4. So remember the period of sine is 2 pi. So what I can do then is use that fact to rewrite this as sine of 2 pi plus 7 pi over 4. And I know that this is going to have the same value as just negative sine of 7 pi over 4. Because every 2 pi the values will be repeating. And now to find negative sine of 7 pi over 4, if you don't have this memorized, what you can do is draw a angle in standard position. So 7 pi over 4 would look something like this. And then from here, we can look at the triangle that is formed by the reference angle. Reference angle here is just pi over 4 or 45 degrees. And if you remember, a 45, 45, 90 triangle has lengths 1, 1, and square root of 2. And so here, I'm going to first put a negative. Now, when I'm looking at sine of 7 pi over 4, we're in quadrant 4, where sine is going to be negative. If it helps, you can always use A as TC, right? Where C, the cosine function, is the only one that's positive there, so sine has to be negative. So what that tells me then, I know I'm going to get negative. And then to find sine of 7 pi over 4, I can just use a reference angle and find sine of pi over 4, which is just opposite over hypotenuse, or just 1 over square root of 2. And if you carefully simplify this out, you should get 1 over square root of 2, and then rationalizing it, you get radical 2 over 2. So hopefully by now you're pretty comfortable with finding trig functions at different angles. Here though, we can get rid of that negative in the beginning by just pulling it out because sine is odd. Let's look at another example together. So here we have secant of negative 270 degrees. And so because secant is an even function, that negative that's inside, I can literally just drop it and pretend like it's not there, right? Because it won't make a difference. And then if it helps, you can write this as 1 over cosine of 270 degrees. And the way you can find 270 degrees is you can look at the unit circle. And if you were to draw 270 degrees in standard position, you would look at the point that corresponds to that angle, that point being 0, negative 1. And if you remember, cosine corresponds to the x coordinate. And so what this tells me then, I get 1 over 0, which is undefined. But again, to make sure you see what we did there, right? We first used the fact that secant's an even function to get rid of that negative on the inside. And then from there, you just use all the properties that you've learned in this whole unit to evaluate the rest. So at this point, I want you to look at number 3. When your video says your turn, I want you to pause the video, press play when you're ready. So for this one, tangent is an odd function. So tangent of negative 7 pi over 6 is the same thing as just negative tangent of 7 pi over 6, where you can just pretty much just pull the negative to the front. And then from here, we can use the fact that tangent has a period of pi. So what I can do is rewrite this as pi plus pi over 6. And then this will just be the same thing as negative tangent of pi over 6. And if you don't remember what tangent of pi over 6 is, you can always draw pi over 6, which will give me a 30, 60, 90 triangle. And then you can label the sides using these numbers here. So if I find tangent of 30 degrees, I do end up with opposite of adjacent, which is 1 over square root of 3. And that gives me negative square root of 3 over 3. And this is your final answer. So make sure you understand these even and odd properties and how we can use them to evaluate trig functions. Review this material before you look at the next video.